Good morning, everybody. Sorry, I've got a little of a computer problem this morning, so I'm not going to share my screen today, but I'm going to go ahead and try and get through this presentation. And hopefully, I can see the comments. But if you do have questions throughout the process, make sure you put them in the Q&A. And if I'm not able for some reason to see them, I will get back with you at the end of class. But for today's class, we're going to continue on our conversation into inspecting our inspection series, focusing specifically on the mechanical systems that we see in buildings as part of that energy code compliance. So just a real quick reminder, for those of you that haven't already signed up, make sure you take time to sign up for the upcoming training there in Hobbs with Hope on September the 10th. There's two different sessions. One begins at 8, one begins at 12. The morning session is going to focus more on the thermal envelope, the afternoon more on the mechanical power lighting systems, with just general discussion and what the code's going, what the code requires, as well as maybe some insight that you as inspectors and plans examiners and contractors have into the different questions that might come up. So it is going to be in Hobbs, and if you have not already, please make sure you send her an email letting her know that you're interested and going to be there. So mark your calendars and be excited and share that information with those around you. But if you do have any other questions, you can always check out our website, get different information on our different resources and available information, technical documents. But let's go ahead and get this started. One of the things I think is incredibly important, you guys hear it every week, right, is that if we understand the why behind what we're doing, then we can better figure out the how. And when we really get into that conversation about inspections, I think it's incredibly important that we understand what it is we're looking to accomplish. And that's to find a way to effectively use and conserve energy in our buildings through flexibility. And we see that flexibility, in my opinion, more uh, recognizably in the actual inspection process, because there's so many different ways we can put together a wall system. There's so many different ways we can insulate and install and think about things like the mechanical system and where it's going to be, how it's going to distribute that conditioned space across our building to be more effective in how we accomplish it. Um, and so that's really where this rationale, this reason, this purpose and intent behind the energy provisions really, to me, makes and starts to become more manifest. I had some long conversations with the friends yesterday, talking about the energy code. I guess that makes me a weirdo, but that's okay. But we were talking about the energy code and how, really the next frontier of this process is not, a better method of insulation or a better process for air sealing. It's more finally refining, like I've said before, refining how we see that mechanical system and how we inspect it. And that's really what kind of drives us into this part of the conversation. So we know that in the New Mexico adoption of for mechanical code for the state, we know that there are some basic expectations about what we expect the mechanical system to do. And that's to provide that minimum, again, that minimum standard of how it's going to operate to provide for heating, cooling, ventilation, and and it also starts to address these other energy related systems. Again, it's not just a simple, it exists, but how does it exist in that focus? And for those who might be thinking, I know a lot of you are designers and might venture into neighboring communities. And so they might be using an IMC, the International Mechanical Code, part of that I code family. Again, very similar purpose, right? We're talking about how we control the operation of this equipment to better provide for a proper ventilation and space conditioning and those types of operational considerations. So again, whether it's UMC, IMC, or more importantly, as in the context of our conversation, the New Mexico Administrative Code sections, the New Mexico Mechanical Code, what we're looking for is the intent is to design a system that both meets the needs of the building as well as provide for energy efficiency. Now, we've talked about before that code compliance and project success begins on paper, right? We've talked about in plan review the different roles and importance that we put in that process. But no matter what we do, and again, this is where the inspections piece comes in, no matter what we do to build or to develop a better plan on how we're going to accomplish the task of building a code compliant structure, we still require those inspections. We still need to get out in the field and verify. We cannot sit at our desk and use binoculars and look across the city. We have to get out, get in the field, and have people there who can verify that what we're expecting to see accomplished is what's actually being accomplished. And so that is really the crux of what we're talking about today. Now, we know, I've talked about it, I'm a simple guy. I like my simple components, my 4 primary pillars of energy code compliance. And in that is our building thermal envelope, our air barriers, mechanical systems, and power lighting. And so today, like I said, we're really focusing in on that mechanical system. But I will tell you that no matter what we do with the mechanical system, it's all based on a holistic understanding of how the building works together as a system, right? We might call them mechanical systems, but really we're looking at how that building as a whole is going to operate. And those other pillars are going to be critical components in that process. But we know that, like I said, there's going to be certain inspections along the way to help us to make sure we get the right building built. And some of those things that we see from the administrative code, from the code, is going to be the requirements for the building official to perform certain types of inspections associated with the rough-in installation of our plumbing, mechanical, and fuel gas systems. And so when we think about that, that's where I think we really can take advantage of the existing inspections we're already doing to kind of understand how we can better, uh, how we can double up on that inspection and not just be there to do an inspection for the duct system or for the mechanical system, but also hit that energy component as well. And when we think about what all the energy code addresses in the concept of the mechanical systems, we know there's a whole series of different sections and subsections that get into it. And some of those resources that we provided in the past and have put on the website are going to be those mechanical field guide inspection field guides, right? What are we expecting when we get out in the field? Remember, this to me is one of those resources, not necessarily always for the inspector, but maybe more so for that contractor who's wanting to know what it is we're looking for when we go out in the field. And so again, we've got those for both the residential and the commercial provisions. And for if there's any questions about that, please let me know. If you've not already downloaded it, please feel free to put that in the Q&A or put that into the survey at the end, and I'll make sure that we get you a copy of that. But again, you can find that at the Xcel website. When we think about getting into this, even in the inspection process, I think one of those important things for us to understand from the beginning is what is our compliance path, whether that's residential or commercial. Knowing that compliance path is really going to help us gauge what it is we're looking for in that building's mechanical systems. And when we think about those residential compliance paths, we think of the prescriptive, which is again, follow the book, do exactly what it says, which is where it's important to understand, am I following the book or am I going to be following a total building performance or energy rating index alternative or some other program that's been recognized by the state, right? If I've got one of those performance metrics or performance compliance paths, I'm no longer looking at simply just the minimum requirements in the building, but I might be looking at how does this all piece together, right? Maybe we've traded off a little bit of insulation in order to get a more efficient piece of equipment in. And so again, I need to make sure I understand what it is I'm looking for. I can't just walk around with the blinder of everything has to have an R49, everything has to have an R30. I need to really think about how is this building demonstrating compliance so that I'm not coming out with this into a meeting. And again, I'm sure none of you have ever said this, but I have heard inspectors say, I don't know what that plans examiner was thinking, but, and we don't want that to happen. We don't want that conversation, that little bit of angst, maybe that's not the best word, but a little bit of frustration to come into the code enforcement process, right? If we look at that compliance path, then we can know, hey, there's a little bit more flexibility here than I'm probably used to in the past or in other projects. And so that's to me one of those key reasons why we understand that, whether that's residential or commercial, right? If I know that we're following ASHRAE 90.1, I'm going to have a different idea or mindset in approaching those mechanical systems, right? I'm going to have a different mindset if I'm looking for, again, if you think about prescriptive compliance, they're going to require those additional efficiency packages that we don't see necessarily directly called out in the other performance alternatives. And so again, it might be something where the minimum code is the minimum expectation with that mechanical system isn't going to pass muster under section 403 because 408 we're taking advantage of some additional efficiency option under 408, and so it needs to be a more efficient piece of equipment based on us trying to get points out of it. So again, can't understate it enough. Knowing that compliance path is really going to, again, hopefully educate me and prepare me as an inspector going into the field as to what I'm going to see. But we know, again, whether it's the residential or the mechanical or the commercial provisions, the mechanical systems are a key component in how we look at the information provided on those construction details. And so we've talked about reviewing that code compliance, and we talk of, in that process of plan review, we've hit on those, or at least I've really reinforced those 4 basic concepts. What's the equipment size? What's the equipment efficiency? What's that duct distribution system look like? And then how do we control it? And when we think about that from an inspections perspective and verifying that energy code compliance, we're going to be looking at very similar things. Now, one thing I want to remind us right off the bat, when we verify energy code compliance, we need to know what pieces of that system are going to be part of a commissioning plan, right? What is someone else going to be out there to verify in the way of efficiency controls, setbacks, those pieces? We're not going to stand there and watch a lot of times if I think a lot about, to me, this is very reminiscent of, some of the fire suppression systems, or maybe even some gas inspections, where we're going to set it on test, and I'm not going to stand there and stare at it for 45 minutes or two or an hour, right? I'm going to expect you to do that test. I'm expecting a commissioning agent to come out and make sure that all of the different dampers work, to make sure that all of the lighting controls are efficiently and effectively operating, right? So there are certain things that a commissioning agent is going to do that I'm expecting a report at the end of this before I finally sign off that says, yes, this has been done. Now, we can talk about commissioning, and I think we'll be talking about commissioning here at the end of the month or in a few weeks, but no, end of September. And I think there's different roles in that process. But again, from a inspector's perspective, I know that based on the plans, I'm going to have some things that are going to be evaluated by additional people. And so that gives me a little bit of awareness as to what's going on, right? And I can reinforce that with my contractor while I'm there. So when's the commissioning agent going to be on? When's your commissioning guy going to get out here? Person. What do you mean? Right? No, I don't want to hear what do you mean? I want to hear, oh, we got to call him after you leave to make sure he can, they can get out here and get this done, that kind of scenario. So again, thinking about those things help us understand the verification process of which we are part. And so when I'm inspecting a building, what am I inspecting for? Again, same things I look for in plan review. What is the equipment size? What is that equipment efficiency? How am I distributing it, that conditioned space, conditioned air, or conditioning across the building? And how am I controlling that whole system? And again, we'll follow this in a little bit of how we look at that mechanical field guide. 1 second as I take a little swig of coffee. Sorry about that. Starting to get that little tickle in the back of the throat. And so again, these are the things that I look for when I go out and do an inspection. And again, I want to reinforce that part of what's bringing me to this point of this what size? Why do I care? I'm out in the field, I'm doing the inspection. Well, why I care is because, again, it's part of the plan. What was that load designed to be? There's a lot of things that whether it's intentional, unintentional, just by happenstance, I'm looking for as I go through this building, right? I'm looking to make sure that the same conditions exist that I know my plans examiner reviewed for, right? Hopefully I know I'm in the right town, right? Hopefully that's obvious. But at the same time, we've gone through these requirements through both the UMC, the ACA standards for residential, commercial, for all of it, to make sure that we understand that what is that heating and cooling load, what is the capacity of that equipment in order to demonstrate code compliance and get us to the point of permit issuance, right? So I know there's a particular piece of equipment that's supposed to be here. And so when I walk in, that's the first thing I'm looking for. Where is it and what is it, right? When I think of, that efficiency, that equipment size, I'm really first off thinking, what is the actual design, right? Am I looking for a radiant floor system, or am I looking for a forced air system, right? What is the system? Because that's going to really have, again, very important impacts, or very evident impact on how this building is going to operate effectively when it comes to energy conservation or energy use. And so if the plan was to put in a geothermal in-floor radiant heating system, and I show up and they've got a forced air gas furnace, I'm going to ask some questions. Wait a minute, what happened along the path? Because I know what was approved based on the documentation that I've got. I'm coming into this with the impression that I'm going to be looking at a particular type of equipment, a particular size of equipment, right? I'm coming in looking for a piece of let me get my pointer out. looking for a piece of gas-fired furnace that's capable of putting out or delivering up to 85,000 BTUs of heat. And I'm finding one that does twice that. Why? What has changed? Right? What is the level of efficiency I'm expecting from that piece of equipment? Right? And it's not. And again, I think that's, I've had several projects here recently that uh, where design professionals have really tried to get as close to eat right on spot, right on target for those heating cooling loads. And a few of them I've actually had where they've come under, just barely under, a couple 1,000 BTUs, 2,000 BTU. Uh, One I had was like 6,000 BTUs, undersized. And so the question really becomes, are you providing supplemental heat? Or are you just hoping that they're now home on the coldest days of the year? So is it the opposite? That you're hoping they're not going to be in town during the hottest part of the year, and they're not, and so the cooling isn't that big a deal. Uh, you know, Regrettably, that's not the way this works, right? We understand that if we've designed the system, it needs to do what the system's supposed to do. And so again, making sure the right size pieces of equipment, the right the right capacity, the right fuel systems based on what we're doing, because that's going to again be driven a little bit by what type of compliance path we're choosing, prescriptive or some other performance method. And so again, it's a question of what kind of size, what kind of efficiency, right? If I'm looking for a condensing unit that's going to meet this 21 SEER evaluation, and I get on site and it's a 15 SEER, you know, is that within the minimum requirements of the code, right? Or and beyond that, again, what type of compliance path am I using? Am I meeting the minimum, or am I meeting 21 because I'm looking at the calculation of how much energy that's going to use in order to reduce something else somewhere in the building? So again, it can't be a simple, well, it matches. I know the minimum is 11.8. ER 15 SEER must be the same, right? We don't know. This is where, again, if it's not what's in the plan, I normally take a step back and say, okay, wait a minute, what's going on here, right? Now, one thing I'm going to tell you right now, I'm having a whole lot of conversations about lately with professionals across the country, has been on this concept of the 410A refrigerant. Uh, you know, maybe not so much maybe not the huge deal in commercial, because you're still going to see it around for a while, but a lot of those systems are coming back in residential as well. We planned it for 410A, and we're going with a 454B A2L refrigerant, and there's some other considerations. We're not going to get into that today. That's a conversation we can always have somewhere else or offline. But again, how are we planning for those appropriate decisions? And like I said, I was talking to a friend over in Virginia, and there is a office or as a department, they're making sure that they clearly identify, clearly notify design professionals and builders as they come in. Hey, make sure you understand the implications of the two, and you make either the correction or you be prepared to come back later and it's going to take you more time. It might not cost you more money later, but it'll cost you definitely more time when it comes to you got to come back with some things. So again, there are certain things I'm looking for that are from that plan. That plan is my cookbook. And if I'm going to make the right amount of cookies, the right type of cookies, then I need to have the right plan. You can tell I'm a little bit of cookie. I'm actually thinking more about brownies or maybe even muffins. It's early. I'm thinking muffins. Anyhow, sorry, digression. So again, knowing what's on those documents helps me better understand. If I'm looking for this size equipment, I'm looking for this efficiency, that's what I'm verifying. Both when I think about mechanical ventilation, mechanical heating and cooling, as well as those service water heating systems. Right? If I've got a series of water heaters, maybe I've got, as we see in this example here, two different water heating tanks, right, that are being provided, then I know what I'm getting out of it. One's gonna be a 50, one's gonna be 120 gallons. I know where they're supposed to be. I know what they're supposed to be connected to. It would be very awkward, right? If we were and to think about it this way, if if I plumbed it and got that backwards, wouldn't we notice it, right? If I plumbed the 119 to service the one side of the building where we had the least number of fixtures, and the 51 on the larger side. So now I've got one that, who cares if it's oversized? I hear that all the time. But I do care, everyone understands caring when it's undersized. And so we're not going to have the temperatures we need. So if we can understand why that would be a problem, then we can evaluate, then we should be able to figure out why it's a problem when it's the wrong type of equipment, piece of equipment, efficiency of the equipment, right? And so when I'm doing that inspection, I very quickly can say, okay, I'm not, very rarely in my entire career have I ever walked up to a piece of mechanical equipment not knowing other than, well, maybe when I first started, right? But never did I get to that point where it was like, well, it's a furnace, or it's a water heater. I'm not sure what it's supposed to be. All I know is it's supposed to be here, right? I knew what size it was, what brand it was probably going to be. I knew what method of fuel system it was going to have. It was going to be electric. It was going to be gas. It was going to be fuel. It was going to be solid fuel. Whatever it's going to be, I'm walking in knowing that I'm looking for a boiler versus a forced air system. And so I shouldn't have that level of frustration when it comes to, well, what kind of boiler? You know, oh, well, we're not doing a boiler, we're doing a heat pump. Okay, air source, ground source. You know, what are we doing, right? So again, digression. But you get what I'm going with. If I'm going into this question, I need to know what's going to be there when I get there, and I need to know where it's going to be, right? Again, what is its function and what is it trying to accomplish? We see that again when we start talking about those hot water recirculating pumps, right? We know where they're supposed to be integrated into a system. So so again, we're making sure it's there, because again, we don't want water. We don't. No one wants to go to a lavatory in a Walmart or at a courthouse and have to wait 15 minutes to wash your hands, right? Because, well, it's freezing cold, and you get out of the airport, and you're not like, okay, I want to rub my hands in that, and you know, and so we want to make sure that that information is available to us and available, and being installed correctly in those buildings. And again, here we see another example of, I know what size tank, I know what size piece of equipment. I shouldn't be surprised when I show up and see, instead of a 50-gallon tank, a 120-gallon tank, right? If it's at 50 gallons and I see a 500-gallon tank come in, I'm going to have some questions, right? And so the same thing, if I'm looking at that tank and it says it's supposed to be a 96% efficient system, and they show up with an 82% because, hey, it passes the minimum requirements. Well, is this prescriptive? Is this performance? And how's that? Or is this prescriptive, but it's also one of those, I'm taking advantage of the more than 95% efficient water heating system. So I have to have a 96 in order to get the points that I need to demonstrate compliance as a prescriptive path. Again, that shouldn't be something I'm making choices in the field. It should have been written in the plans and executed in the field. And when we think about the size of that equipment, that again, I know I probably a broken record. It always gets me, we start talking about how we size that delivery system. I've seen too many times when we've come in and we've changed this out. And so we have to recognize that the fuel gas code tells us we need to size that pipe, that delivery pipe, right? To meet the requirements of that piece of equipment. And so again, I see this especially when we start talking about Chapter 5 and replacements of existing systems. We'll talk a little bit about this maybe when we get to that conversation in late September. But again, if I've got a design that's laid out as we see on the screen with just a simple gas-fired range, gas-fired furnace, and a gas-fired water heater, and then I decide to change one of those because I just do, right? It's time for a replacement. I had to almost replace my water heater here recently. And so the question really first started to come up again. Do we go instantaneous? Well, what's that impact? You know, for me, it's going to be a huge impact because I have an electric water heater. So if I go from electric to an instantaneous hot, I'm going to be adding in to a system that already exists. So I need to make sure that it's sized properly as far as that fuel line, right? I need to make sure that that entire system is going to continue to operate effectively and appropriately. And so again, I've told you before, too many times I see it as, well, it's a like for like. I'm just swapping out a refrigerator, a water heater. It's all I'm doing. Get the phone call, right? Hey, I'm doing a water heater over here on 123 Hannah Court. Do you need anything from me? No, just put it on the computer. We'll get you covered. Well, what we should have said is, I'm replacing an electric water heater with a gas water heater. Do you need anything from me? Oh yeah, I'm gonna need a line drawing, right? What's the gas line gonna look like? You know, do you have capacity? Do you have a regulator that'll allow you to do that? Right? Those are big questions to be asked. And again, remember that the systems that we have today being put in buildings today, new construction, is completely different from old construction when it comes again to that replacement and modification. I saw one the other day where they were doing a remodel, adding an addition, and that addition came with a brand new furnace or heating system, as well as a fireplace. So it's like, did we make sure that now we just check all of the components that are part of that gas line? And so again, it's no longer just a range, furnace, and water heater. It's a range, a dryer, a water heater, a furnace, a grill, a fireplace, maybe a sauna. Who knows what's coming into that building? And so again, we want to make sure we're getting the right design in place. But after I go through that whole process, right, I've evaluated the equipment size, the equipment efficiency, then I really start to get into those more, what I call more functional pieces, right? That as I'm walking around the building, I'm going to start to evaluate that duct and those controls. And the first thing I think of when I think about my mechanical systems is isolating and determining where is that mechanical room. Now, in our documentation and our field guide, we call it a mechanical room in order to really recognize that we need to understand where that thermal envelope is and what level of thermal protection we're offering in relation to that equipment. Right. So if that equipment room is bringing in unconditioned outdoor air, right, combustion air from the outside, as we see coming in here, right, then we need to make sure we isolate this thermally so that we're not impacting the surrounding area without consideration. So again, that's simple, but what we're really thinking about is, where's the mechanical room? Where's it getting its combustion air from? And what do we have as protections to make sure we're not creating a heat loss in that area? That is also a place where, again, it reminds me, it reinforces for me, what is it I'm looking for in that building? Where is that thermal envelope, right? So that I know what systems, what components, what parts of that duct distribution system require insulation or require other protections, right, for heat trace or something like that, depending on what we're looking at. And again, part of it is understanding what is the function of the building. Going back even to the very beginning, I know there's a heating load calculation, and that heating load is telling me this space is going to be used for this one particular reason. And then when I get there, I find out it's not, right? We went from just a simple parts building, a warehouse, to a warehouse with offices. And I've told you this story a million times, but I think it's just representative of reality, right? We go out, and sometimes there is the chance that we're going to find out that what we find in the field doesn't come close to what we expected. If we were just going to go out and just say, hey, give me a report at the end of the start today, give me a report at the end that everything was fine, right? The report at the end of the process would be everything was fine. Things changed, but everything was fine, right? We need to have a little bit more detail about that. And so again, part of what I'm doing when I do inspections, whether it's knowing where I'm looking, also knowing what I'm looking for, right? And so again, when I go out in that field and I'm looking for those actual heating and condensing units, so you see here we've got a couple, a gas-fired heating unit. We've got a couple different condensing units out. When I get on site, I can look for those devices, right? I've got one heating unit for this entire facility, right? That sounds a little bit underserved, right? But again, I'm going to go back and defer back to, did my plans examiner do their job? Did the designer do their job in calculating that? That's on them. I'm making sure that I'm doing what that plan says. And again, I've got one gas heater, I've got a couple different fans, but I've got 4 condensing units. Now, a lot of that's going to go to serve these office spaces, right? These 60 some offices that were, or 40 some offices that were put in, 2-story office area. But again, I need to know where those ducts are, what they're supposed to be in as far as that building thermal envelope, and how we're controlling that air, right? The same concept that we see in residential. I need to know that we've isolated, that we've sealed this. Again, a buddy of mine and I were having a conversation just yesterday about the role of air sealing and what it's done for existing homes and the amount of energy consumption that goes into them. And so again, we want to make sure we think about that. The building code, the energy code lays out some minimum expectations, and those are that we consider the impact of air sealing, of air loss and heat loss in those buildings. And again, that's part of that mechanical room that at least what we put down, I put it in that inspection field guide, the mechanical room. But again, here we see another reminder of my building thermal envelope in orange here, and then my duct systems that exist in these unconditioned or these semi-conditioned spaces, right? We've got the conditioned space inside the offices and the corridors, but what I'm not getting is, is this a structural member or is this a thermal barrier? Well, it's not listed as thermal, so again, I'm expecting this is probably part of that whole open parts storage area. So again, is that one singular gas heating unit going to be sufficient to provide that minimum, that temperature that we need? Or are we going to have to, again, insulate, which I guarantee you we're going to have to insulate these ducts, because again, we're not going to have they're not in a conditioned space, right? The semi-heated nature of this building, the semi-conditioned nature of the building, we're going to have condensation out the wazoo. That's a technical term. We have condensation at extreme levels because, again, we're looking at a building that is not properly or continuously or consistently going to be heated to a temperature that doesn't allow for that condensation, that humidity control. Another example here, if depending on where I'm looking as an inspector, and one of the things I'm really trying to get better at is in this role here at Shums, is trying to get good pictures of good things, not just pictures of bad things. I did a building the other day, and I'm like walking around, like, I gotta take a picture of everything because it might be good, right? Story of my life. But so again, making sure that when we look at a building, we completely understand. When I walk out on the site, I want to know where that thermal envelope is. And again, this takes me 5 minutes to figure this out when I'm pulling up to this job site, because this vertical wall difference, vertical chain, these vertical lines tell me that there's going to be different areas that I need to think about. That the conditioned space in the office is going to be different than in the body shop or in the paint booth. Because when I look at that paint booth, I'm going to see they've got a big fan and they've got 4 heating units. Well, actually 2 in the wash bay, 2 in the paint booth, right? So you see that wash bay, paint booth, wash bay, paint booth. And so again, here I've got I've got a fan, I've got some gas heating units. That's what I'm looking for in my inspection. Are they there? How are they being fueled? What am I looking for as far as, again, continuity of my thermal envelope? Same thing when I look at that larger service bay area. I've got some heating units, right? The longer radiant heating systems to allow for that heating of these openable areas. But then I've also got exhaust vents. I've got fans, right? I've also got controls, which are going to explain to me what those expectations are of when those fans work and operate in relation to the overall building. right? So again, these are considerations that really uh, we spend a lot of time in plan review and design considering, and now we get on site. I want to make sure they work, and a lot of this is not going to be something where, hey, um, can somebody open that door and make sure that we have the CO2, you know, oh, what did I do? The CO2 sensor doesn't go off, and so that's, or that the CO2 sensor triggers the fan. I'll be honest. I'm expecting that a commissioning report that's going to be checking that, because again, I can see you turn it on, I can see you turn it off, but I'm not going to stand there and make sure that every sensor activates properly. That's a commissioning agent, right? And so again, I can see the fan, I can see it work, I can see it operate, I can see that it provides the appropriate, it's properly wired, properly installed on those kinds of things. But again, I'm limited in what I'm expecting to do. And I'm really deferring to that third party, that independent evaluation or inspection, just like I would in maybe a structural steel inspection, right? Or a special inspection. Give me that commissioning report so that I know this equipment is going to operate the way it's supposed to. I evaluated, verified it's there, it's properly wired, it's functional. Now you make sure that it controls the way it's supposed to. And again, we're not talking about lighting, but I told you about my story about lighting. Again, I'm not going to sit outside and wait for the lights to turn on, right? I want to make sure that you have a commissioning agent to do that. And the same thing when I start to think about that functionality, again, that drives you back to this, how are we properly sizing those ducts, right? It's more than just making sure they're properly located within the building thermal envelope that they're providing. Again, a certain, but it's looking at the functionality of it. Is this the right size? And again, that goes back to the design saying this is supposed to be a 8-inch duct. Well, what happens if I come in and say, well, we didn't have any 8-inch, we had some 12-inch. It'll be fine, right? No, it won't. I'm not going to take that as an inspector. I'm not taking on that liability. We had a long conversation earlier this week about with some engineers that I was in a committee I'm on, about liability and who's responsible. And everybody knows that everybody's trying to cover or limit their liability in making these decisions. We have designers that create plans. We have plans examiners who review those plans, and then we have inspectors who verify the plan, right? Or builders who build the plan and inspectors who verify the plan. And in that whole process, when something goes wrong, everybody gets pointed at. And so, was this the right installation? Well, did we check to make sure that that's the right, based on its location within the thermal envelope, that this is the right size, the right value of thermal resistance? That's a great question, and that's part of what we're looking for when we start looking at those duct systems, right? It's more than just looking at the space or looking at the room or the relationship to our thermal envelope, but looking at the actual insulation associated with it, right? We understand that there's a variety of different items contained within both the IF, the fuel gas code, and the mechanical code on the requirements for duct installation and duct construction, right? And in those expectations, they even address the requirements for duct insulation. It's not about, again, improving or affecting the thermal conductance or the thermal capacity of that equipment or that distribution system. It's all about regulating that condensation potential, right? And that's, again, where we see it when we look at, again, section 603 of the IMC. And 603 reminds us, and whether that's in the IMC or in the UM, so it's 603.2 in the IMC, goes back to ACA Manual D for residential, ASHRAE bucket fundamentals or other approved methods for commercial. New Mexico's mechanical code, and the UMC is 601.2 that talks about duct sizing requirements. And again, takes us back to that Manual D for those ASHRAE bucket fundamentals or other approved methods. Because again, what we're looking at is, you just can't throw two pieces of a piece of sheet metal together and say that's going to work. We want to make sure that we've done the calculations to determine, am I getting the right amount of airflow at the right room in order to verify that I can properly and effectively change both the space conditioning and the indoor air quality or ventilation requirements of that space. So again, we know the right what's supposed to be there. We need to make sure it's there. And if you get into really, if you want to have a lot of fun, start talking about the importance of diffusers and vents and vent selection on room airflow, right? And you can have a whole conversation about the right vent and the right location can make or break a conference room, an office space, a house, right? You know, many of us may know of structures, and maybe even we work in them, where yeah, there's certain rooms where it's just untenable. Why? Because it's not properly ventilated, right? The duct sits here in the middle of the table, flows directly down this table, and then every time we sit at the table, the everything moves, right? All the paper gets blown away. Why? Because the duct activates. Once the sensors go off that we need air into the space, then the duct turns on and it's too powerful and it diffuses improperly, and we get paper movement, right? Again, I've personally I've worked in an office where they changed the rooms more than they changed the ducts, and so they would add a wall here and add a wall there, and it would affect significantly how those spaces worked as workspaces. I'll just leave it at that and move on. But knowing that amount of that duct system is a reflection of our overall air balancing, right? We talked about whole house, no, we talked about swimming pools last week. When we talk about, you know, the air balancing requirements of the building, we talk about that ventilation. We know what areas of the building need air, right? And so we need to be able to, again, think about when I'm doing that ventilation inspection, when I'm doing that hood, am I checking for, again, an automatic damper to where I don't have uncontrolled air loss, right? You think that's a small thing, but again, it can really affect how that building's going to operate, right? So what type of dampers am I looking for? What type of control sequences, right? That if I'm turning on the rooftop units, am I still going to have some other exhaust fans operating? Which exhaust fans are going to be working continuously? Which are going to be intermittent? You know, what are their disconnects, connections, and controls? And again, I'm not probably going to be walking around each one of these, right? I'm going to have a lot of times a commissioning agent. Now, depending on the size of the building, we might not have a commissioning agent. And so it's going to be a question of, you know, where's the control to turn on this system or turn off that system? You know, what happens when, you know, do you have an economizer that's going to recognize that given the temperature, we need to either bring in air or take out air, right? Our direct outdoor, our DOAS system. There's a variety of different things we can think about in the mechanical design, and how do those pieces of equipment all work together? But it's not just a question for the commercial building, it's also a question for the residential design, right? We know that we're looking for air movement, controlled air movement within that building. We don't want that stuffy, my house, the stuffy room that never gets the right amount of air is the laundry utility room, right? It has one duct, it's in a poor location, and it's at the end of the run. So it has the least amount of pressure. I brought out the anemometer, right? I've brought out the little measuring tool. I can use if I wanted to, I could go back over the thermal heat gun and show the difference between a duct that is closer to the furnace than that room. And so again, it's poor design, it's poor layout. And again, whether it's residential or commercial, we can see that in the building. And that's what we're looking for, is the appropriate layout. And one thing that I always hit on a lot with my plan review is making sure I have that good example, that visual depiction of those fittings. Because again, that's just annoyed me as an inspector. When I'd go out there and I'd see a diagram that was like a line drawing, and I have no clue what's supposed to be there, other than there's supposed to be something here. I know something's supposed to be here, but is it going to be a T, or am I looking for or a Y? I don't know. It, just put something together, I guess. Right? No, I can't do that. Right? You know me. I couldn't live with that. And so again, making sure that what we're expecting to see is what we're expecting, is what we're finding on the plans. We know that those designs that we talk about, right? That's part of that manual D, that approved engineering report. Is going to be looking at how does that system design, right? Did we calculate for round ducts versus rectangular ducts, and that how that air moves across that building? I had this conversation again with in a co-development meeting the other day, that what is and then the individual asked, as a jurisdiction, what's the expectation for when you say you want approved designs, what do you mean? And the answer was, there's no set amount of information, but what I need to know is that this is going to be a safe building, that it's going to be a code compliant building. And so if that's 1 page or 50 pages, it's not a question of there's no right or wrong answer. I'm going to know when I have adequate details. Do I need 114 pages as minimum? No, but I am going to need to know that you did something. I did a project just the other day, and hopefully they're not online with us today. Shouldn't be, but just in case, I won't use names. But in this design, all they submitted was a letter that says the project will be to whom it may concern, this system was designed in compliance with the manual D. Okay, so you didn't give me anything other than just your letter that it's been designed. You didn't show me a design. You didn't give me a mechanical sheet. You didn't show me a layout. This is a rather large building, and we're just going with it'll work. And what made it even more interesting was that the person making the attestation, try saying that real fast. I'm in my legal mode today. Was making that statement on that piece of paper. Yes, they were an architect, but they were also the project owner. And so it was like, well, they weren't an architect, or an engineer. So let's make that clarity, right? But it's like, again, I'm sorry, you're going to give me a little more than that. I'm going to need to see a drawing, see the fittings, and see the calculations on airspeed, airflow, ventilation requirements in the building. Same thing with, I'm not just saying, well, this is the right, I mean, that's to me the same as saying, well, Murray says that this is the right size piece of equipment for that house, so it's got to be right. No, nope, we're not going there, because again, I'm not going to be responsible for that. So again, looking at those designs, seeing, what kind of design have they put in to calculate that static pressure that we're going to need for the building, right? What is those equivalent lengths of designs? And so it's more than just saying, yes, this is the right ducts because it goes in the straightest line possible, and this is the one place I want the vent, versus where the vent is actually the appropriate capacity. And so again, I want to see a diagram, maybe not a drawing like this, but a diagram. It says where these things are supposed to be, so I know what and again, that cut sheet, that fitting sheet that tells me what an 11M is versus a 4X. And so we see these 11Ms everywhere. What are they, right? And again, here's another example. Tell me more. What is this 4AD supposed to be? I get that we're getting 56 CFMs in a 12 by 4. I'm assuming that's the size of the vent, right? But a 4 by 12 and 37, but like these exits are these, I'm assuming these are these returns? Are these, I'm going to be honest, I'm not into the guessing game anymore. I've given up trying to guess. Now, I'm pretty sure when I got out there, I could probably figure it out. But I got a return riser. oh, what is this? You know, again, I'm just gonna be honest. I'm not guessing. At no point in this process am I going to sit again. You guys know I'm afraid of lawyers because I used to work with too many of them. I'm not going to sit on a stand in a courtroom or even in a deposition and say, well, what is the 4AD? Well, we never really did find out. And when I did my inspection, I really didn't look for them because I wasn't really focused on it. I looked at the piece of equipment, saw there were ducts in the wall and the roof, and I walked out. Uh, I'm not going to say that, and hopefully none of you would ever say that either. But again, we need to understand all these components because that's part of that inspection process. We're expected to make sure that not only is the equipment installed right, and that the ducts are properly installed, connected, hung, supported, whatever term you want to use, they're probably supported, properly sealed, and that we've got the appropriate designs, right? But if you notice, most of these lines look pretty similar. We've got a 6-inch, a 5-inch, and a 6-inch. It's really not that discernible is the difference. And so again, I'm not using my eyeballs. I'm looking for notes and guidance on that. And the same thing, even in a simple design. What are we doing to dissipate the air through the building? Because what I'm not going to be expecting is, what was the calculated distance? Well, what is the equivalent distance when the pipe goes like this? You're expecting a 10-foot pipe, not 20-foot of pipe that goes 10 feet, right? Versus something maybe a little bit more like this, where again, these are office spaces. And so again, this gives me a very straight linear calculation of that distance, that equivalent length, that this is going to get lost in, right? If you were calculating the airflow, and what you're going to get out of here is probably not what you're expecting to get out of that run, right? Because again, it's not in a consistent design. Let's just call it that. And so whether it's going to be whether that system is integrated with hoods or other venting, again, what is that fitting supposed to look like? What am I looking for? Ridge, smooth, oval, circle, square, rectangular, don't know. Give me some flexible versus ridge. Give me some information so I know that the ductwork, the ceiling, the insulation, all of those components are properly installed, right? I know what I'm looking for. And sometimes you'll find insulation even when it's not required. And again, there's nothing wrong with that so much as making sure you understand that what is the minimum expectation of this system, right? If this was supposed to be insulated, then I'm expecting insulation, not insulation that stops. Now, this one I think is doing it more for, because of the condition, it's more for sound attenuation. There's a couple other reasons. But again, if it's required, I'm expecting continuous insulation. We've talked about this. I use this picture a lot to represent, liberally applied versus not so liberally applied sealants, right? We can clearly see that the sealant around this connection is not going to sustain very long. I'm sorry, maybe I'm too, maybe I like my peanut butter too much, but this is not going to, in my estimation, going to sustain itself against consistent air movement through this duct system. And so I'm going to look for what's that manufacturer say was supposed to happen. And what I'm going to find is the manufacturer said tape and seal, right? Or liberally apply a sealant. And so they didn't tape, they didn't liberally apply, they slathered on lightly, like what looks like a butter knife, and that was the end of the process. And again, is this the appropriate type of connection or sealant between those two, where that insulation is ending? Again, I had a conversation with someone the other day about installation, and they were talking about installing fiberglass underneath a slab. And it's like, well, I appreciate the concept, but I think fiberglass will compress under the weight of a slab, so it's not going to be effective. And just like this insulation that we see here is not being effective by providing that R13. Now, again, if it sounds different, that might be different, but we can kind of see there's some insulation associated with it. So when I'm looking at a duct system, I'm looking for that protection. I'm looking for that penetration. I'm thinking about these systems. And if I'm seeing something like this, I'm not going to be the happiest when it comes to, again, the amount of that sealant. I got to go a little faster. We only got 2 minutes, a little over 2 minutes left. We're talking about hydronic heating. How are we insulating? How are we thinking about that pipe? And again, one of the things to think about is a lot of times we see it listed as a thickness of insulation rather than a thermal resistance value. So in future versions, we'll see that correction. But again, make sure that we're reminding ourselves that we're not just looking for a ½ inch of insulation. We're looking for insulation that's at least that R3, right? So that, again, we're getting that both thermal and thickness, so that we can make sure that we're protecting it properly against heat loss and condensation. But we're not always just protecting against that. We're also protecting at times against damage from the sun or from physical contact, right? And so again, we might have different types of insulation associated with different designs. And part of that process is just making sure things are done right. You know, whether they're dropped down as part of that ceiling or they're just cut through completely, right? We want to make sure that if we're doing this inspection, I'm not just looking for one thing, I'm looking for everything, including when those penetrations go through potential firewalls. So if it goes through a firewall, we're going to seal it, right? There's certain expectations. And if we're protecting that firewall, we're also protecting that exterior thermal envelope. And so again, we've seen this before. We know what we're looking for. We have penetrations. We want to, again, make sure that they get all that properly sealed. Last thing that we're looking for, again, is that control. And I know I've got like less than a minute or so. And so remember, we're looking for those controls in that design, looking where they're at, what they're supposed to be doing, so that we know what to look for, where to look for them in the context of everything going on. We're looking at fans and coils. We're looking for controls, thermostats to control them, lines that take them back to the heat pump. All that's part of this process. And that's part of also understanding when is something inside the building versus outside the building. When are we looking at openings that need curtains or some that are interlocking controls? We talked a little bit about pools last week, and again, those might be systems that we're thinking about, like I said, the interlocking control. We do the installation inspection. We can also see here they messed up some insulation in the process of running some lines. So again, it's more than just looking at one thing, it's looking at everything, including those air sealing. I know we ran out of time there, and if you do have any questions, please feel free to throw them in that chat, put them in that survey. And so we can get back with you again next week. We'll be doing some more training, but remember, September the 10th, we do have that in-person training there in Hobbs. So if you're interested in attending, let Hope know that you'll be there. And you can always check out our website about different information, find our different resources, or you can always email us at innhelpline@shumsco.com. You guys be careful. Have a great weekend. Be safe. And I will see you again next week.